vast expanse of the cosmos, from the celestial bodies to galaxies, a fundamental query resounds, demanding elucidation. Why does something exist rather than nothing? This quandary escalates when one contemplates the symmetrical nature of the physical laws that govern our universe, seemingly impartial between matter and antimatter. Yet as we gaze upon the cosmic tapestry, we discern a predominance of matter with antimatter in scant supply. Thus we confront the conundrum of our own existence amidst this universe teeming with stars, galaxies, and the enigma of being. What intricate cosmic forces conspired to birth this world as we apprehend it? What profound mechanisms orchestrated the tipping of the scales, bequeathing us this universe replete with galaxies, stars, and the riddle of our own existence? And how did this grand spectacle unfold? The inception of this unimaginably colossal universe has been a subject of contemplation for eons. Early scholars surmise that the universe endured in an unaltered state, a perpetual cosmic clockwork governed by the immutable laws of physics. However, in 1927, a Belgian priest and savant, George Joseph, proffered an alternative notion. He posited that the universe's genesis lay in a primordial, gravid atom which detonated, disseminating the smaller atoms that form the cosmic tableau we now behold. This proposition remained largely unheeded until 1929, when astronomer Edwin Hubble unveiled a revelation. The universe is not static but rather expanding. If this expansion were retraced, it should lead to a minuscule, dense singularity. The term Big Bang Theory, coined mockingly by the eminent astronomer Fred Hoyle, was later adopted by its proponents. Undeterred by skeptics, scientists Ralph Arthur, George Gamow, and Robert Hummon prognosticated that an afterglow, a faint remnant, would linger if the Big Bang had indeed occurred. In the mid-1960s, astronomers Arno Penzias and Robert Wilson stumbled upon a pivotal discovery while endeavoring to attune their radio antenna to the signals from the Milky Way. Persistently, they intercepted a faint hiss of radio waves, an enigma they sought to eliminate. Unbeknownst to them, this hiss was the echo of the Big Bang, known as the cosmic microwave background radiation. In this cosmic overture approximately 13.8 billion years past, all the substance of the universe emanated from a solitary, infinitesimal singularity in a cataclysmic detonation. This infinitesimal point expanded at an astonishing pace, doubling in size every infinitesimal fraction of a second, birthing space in its frenetic inflation. Gravity and the other fundamental forces coalesced in a fraction of a moment. Energy transmuted into particles of matter and antimatter, with the latter predominating in their mutual annihilation. Miraculously, some matter endured, giving rise to protons and neutrons. In mere minutes, these particles fused, engendering nuclei of hydrogen and helium. After roughly 300,000 years, these nuclei could capture electrons, begetting atoms that suffused the cosmos with nebulous clouds of hydrogen and helium gas. In their wake, a residue of photons, the cosmic microwave background, within this maelstrom were infinitesimal undulations of matter, stretched to cosmic proportions during inflation, birthing the seeds for galaxies and their clusters. As we peer into the cosmos, the compendium of our observations, despite acknowledged uncertainties, converges to paint a remarkably coherent portrait. Our universe, replete with galaxies, stars, planets, and ponderous elements, adheres to the same immutable laws of physics ubiquitously and eternally, governed by general relativity. It expands, cools, gravitates, and is pervaded by dark energy and dark matter, with conventional matter, neutrinos and radiation constituting the remainder. This expanse, as we now behold it, was not always thus, but evolved through cosmic epochs. In a remarkable feat of scientific acumen, 20th century scholars pieced together the chronicle of our universe's transformation from a predominantly uniform expanse, devoid of intricate structure, to the richly articulated cosmos we survey today. Should we journey backward in time from the present, inquiring into the origins of any particular structure or component thereof, we are inexorably led to an enigmatic precipice of unknowing. It is a realm where we are compelled to acknowledge. Not yet do we apprehend. At length, we are prompted to contemplate our present reality and inquire. How did this arise, and might it have emerged from naught in the genesis? The vitality we presently cherish is a consequence of minuscule particles that constitute the essence of all that surrounds us. These particles aggregate into intricate molecules, the building blocks of life. At the core of these constituents lie atoms, elemental units that underpin the entirety of the cosmos. Yet, these atoms did not materialize ex nihilo at the universe's inception. Rather, their genesis was a protracted process entailing the birth, life, and demise of stars. When stars meet their celestial demise, they bequeath new substances through prodigious thermonuclear reactions. These newfound elements then serve as the crucible for the formation of nascent stars, perpetuating an unending cycle that is requisite for the existence of celestial bodies and the intricate tapestry of chemistry. For the universe to harbor the stars and galaxies we now behold, pivotal events were imperative. The gravitational amalgamation of diminutive stellar and galactic assemblages, the presence of mass to initiate this process, and the coalescence of dark matter in its nascent stages. Moreover, a precise balance of diverse forms of matter and radiation was necessitated to yield phenomena such as the residual glow from the Big Bang and the rudimentary elements from which galaxies and other celestial structures would emerge. Furthermore, slight perturbations in matter density were requisite, as these disparities burgeoned over temporal epochs, galvanized by the omnipotent force of gravity. These initial imbalances, in concert with the advent of dark matter and conventional matter, were pivotal in the genesis of all that we now perceive. In the nascent phase of the universe, matter and antimatter were accorded equal footing in the annals of physics, wherein reactions engendered or annihilated both in commensurate measure. At the universe's onset, the cosmos could have spawned prodigious quantities of both, owing to the extremes of temperature and density. Yet, by some enigmatic mechanism, the universe bequeathed a surplus of matter over antimatter, despite the two being theoretically equipotent. Diverse scenarios might account for this asymmetry, though which of these transpired remains uncertain. These potentialities hinge on three cardinal elements: unique conditions of imbalance during the universe's expansion and cooling phase, processes that transgress customary norms, enabling interactions that procreate more matter than antimatter, and the standard model of physics, which accommodates such an outcome through phenomena known as Valeron interactions. While this model comprises these notions, it is not self-sufficient. Thus, if one were to contemplate a universe characterized by parity between matter and antimatter as tantamount to a universe of nothingness, our present reality suggests that, in some manner, the universe did indeed spring forth from a state of apparent non-being, notwithstanding our incomplete grasp of the exact modality. Dark matter, a nebulous enigma that exerts its influence on the cosmos, presents a panoply of potential origins, each contingent upon exhaustive scrutiny and research. This elusive entity eludes classification within the standard model of physics, necessitating a departure from our present understanding. Conceivable origins range from emergence during the incipient fervent phase of the universe to enduring as an enduring relic of an epochal transition. The myriad conceivable scenarios are united by a common requirement: energy. Yet, the question persists. Whence did this boundless font of energy emanate? In accordance with the tenets of cosmic inflation, the preeminent theory delineating the antecedents of our universe, this energy may well have emanated from a state that, at first blush, appears to embody the void. Picturing the dawn of the incandescent Big Bang, one envisions a crucible of superlative heat brimming with prodigious energy. This genesis defies the facile binary of causality or randomness, offering two distinct philosophical vantage points: acquiescence to the enigma of primordial conditions, or the quest for an elucidating theory that accounts for these foundational parameters. Enter cosmic inflation, a transformative paradigm shift that redefines our perception of the universe's dawn. Rather than envisaging the onset as an infinitesimal point of extreme heat and density, inflation posits a prior phase wherein space itself bore an inconceivably elevated energy density. This precipitated an expeditious expansion of the universe. With the cessation of inflation, this exorbitant energy metamorphosed into matter, antimatter, and radiation, begetting the aftermath of the Big Bang. In minute detail, this inflation not only engenders a universe marked by homogeneity and a planar facade, but also prognosticates specific forms of density fluctuations. Remarkably, these fluctuations comport with the predictions of inflation arising from a nearly vacuous space imbued with latent energy. In this manner, a natural process begets the entirety of the universe, resplendent with its manifold structures. Imagine a scenario that deviates from the conventional genesis of the universe through a singular colossal collision, one transpiring within the unseen tapestry of higher dimensions. This constitutes the crux of the equirotic universe theory. Here, our universe transcends the familiar quartet of dimensions, embracing an additional dimension that eludes direct perception. This dimensionality is akin to a cosmic plane, suspended within a larger, unfathomable reality. The moniker equirotic derives from the ancient Greek, evoking imagery of a fiery cataclysm. This theory fundamentally reorients our understanding of the universe's inception. It propounds that our universe is not an outcome of the conventional inflationary model, wherein rapid expansion ensues through the agency of an enigmatic field.